Hello, I'm Stephen Jackson. I'm Professor of Cognitive Neuroscience at the University of Nottingham. So my research in Tourette Syndrome is focused on understanding where tics come from and how they might be controlled, and particularly in developing new treatments, particularly non-drug treatments, that might be useful in suppressing tics or helping to build on the brain processes that are involved in suppressing tics. So what we already know about Tourette syndrome is that it's linked to subtle changes in brain networks, particularly brain networks that involve a structure called the basal ganglia. And this leads to increased excitability, so the brain areas become hyperactive, particularly in these motor regions, and we think that gives rise to tics. So our work uses brain imaging, so MRI scanning, but also other techniques to study brain networks in each individual and to look at how we might reverse some of these excitability changes. And one of the techniques that we're most interested in using are non-invasive brain stimulation techniques. So one sort of non-invasive brain stimulation technique is called TMS, or transcranial magnetic stimulation, and this is a safe, reliable and painless way of modulating, so changing the excitability of targeted brain areas. And by using these techniques, we hope to be able to reverse the effects of this increased excitability, so this unbalanced excitability, and therefore reduce tics.
I'm Georgina Jackson from the University of Nottingham, and I'm based in the School of Medicine. So my main interest is really on seeing how we can help children with Tourette's gain more control over their symptoms so that they can better manage the symptoms that they have. I've done quite a lot of work looking at how well they do on a range of behavioural tasks that measure their ability to control their behaviours or delay an action. And we actually found that individuals with Tourette's often do much better than age-matched controls, and depending on how severe their tics are, the less severe their tics are, the better they are at these sorts of things. So this has led to a number of studies where we've been looking to see whether or not this ability to control their behaviour on these tasks may be tapping into mechanisms that are involved in suppressing their tics. I'm also interested in how we can boost those abilities to control tics and use non-pharmacological methods to do this. And that's resulted in some studies that we've run looking at the effects of physical activity. And we've demonstrated that performing aerobic exercise reduces a child's tic, not only while they're doing the exercise, but that this activity maintains a reduction in tic symptoms for at least 45 minutes after their tics. And we're talking about a 2/3 reduction in the tics that they have. So that's a very significant amount of improvement that you see. Unfortunately, we haven't done studies for longer periods to see how long-lasting that might be. But we are starting to try and understand what's happening at a brain level that may be helping to improve their control when they do physical activity. There's lots of studies in the elderly that demonstrate the importance of physical activity for improving brain function, and as well animal studies that are relevant here. Another topic that I'm currently working on is one of learning. I think it's very important that we understand more about the way in which tics are acquired, learnt and unlearnt if we're going to really improve the sorts of behavioural therapies that we do with children. So we have a number of computer-based tasks where we've looked at how well they learn motor actions and how long those motor actions, once learnt, remain affecting their behaviour.